In the last video, we created a robot consisting of a differential drive and 2 light sensors. We also created a scene consisting of a ramp to confine the robot to a small area. In this video, I'll demonstrate how easy it is to make changes to your robot, the scene, and the code that controls the robot. In this example, we want to have the robot follow and ram into any balls that it sees. At this point, we have created a project to control your robot as instructed on the Learn page. These instructions set the power of the left and right wheel to have a constant power of 0.4 and 0.3 respectively. Let's run the simulation to see how the robot does in this simple test case. The robot tries to climb the ramp and gets stuck. Now let's go back into the controller project and add some code to drive the robot. Let light from the right sensor drive the left wheel, and light from the left sensor drive the right wheel. The wheel power should always be a number between -1 and 1. So let's make sure of that. Now, instead of sending a constant 0.4 and 0.3 to the drive, we'll use the values above. Let's run the simulation with the new code and see what happens. The robot rams into the ball, then gets stuck on the ramp. Let's look at what the left sensor sees. The robot sees light from the sky and thinks it's a ball, so it tries to climb the ramp. Going back to the main camera, we see the robot is stuck on the ramp. It needs to back up when there is no light. To make the robot back up, subtract a small value, say 0.1, from the brightness sensors. So when it is black, the robot backs up. Let's run again and see what happens now. The robot does back up now. The ball went in front of the robot and the robot started turning left. This is because the sensors are read every half second. So the left sensor saw the ball, which drives the right wheel, and the right sensor didn't see the ball at all because the sampling rate is too small. Let's read the values from the sensors every 1/5 second instead of 1/2 second. Also, we'll send commands to the robot every 1/5 second. Let's run again. The robot didn't see the ball when it was almost in front of it. Let's go back into SketchUp and place more balls in the scene to study this better. Let's move the ball so that rolls down the ramp. Using the Move tool, we can move it in the XYZ direction. Let's move it a little higher up the ramp. Now let's create several copies. Using the Rotate tool and holding down the Control button, create one every 30 degrees. Let's make 3 copies by typing in 3x. Now let's run again. Let's export by pressing F5. Then in Visual Studio, press F5 again. The robot may respond better if we change the X view size and the Y view size of both light sensors. So let's go back into SketchUp. Click on each sensor and then click Inspector. Let's change the Y size to 16 for both sensors. Also, let's widen the X size a little bit for both sensors. Let's set the X size to 64. Press F5 to export, and go back into Visual Studio and press F5 again. When you write code to control your robot and run various test cases, you will find yourself making changes to your robot, the scene, and the code that you write. When you are done with this process, your code works in the virtual world for all your test cases. Next step, build the real robot. I hope this video demonstrates the iterative nature when developing using AR.